In this video, I'm going to talk about geometric series. First, I'm going to define a geometric series. After defining it, I'm going to go ahead and find the partial sum for a geometric series. And from that, I'm going to find the total sum. Once we have found a formula for geometric series, then I'm going to go ahead and figure out under what circumstances does a geometric series converge and under what circumstances does it diverge. So let's go ahead and get started. Let's consider a real number a. A is a constant, okay? We are making the assumption that a is non-zero. Then we define a sequence. First, let's go ahead and define a sequence. A sub a times r square, okay, a times r cube, and it keeps going. So this is a geometric sequence. If you look at the individual terms, what you notice is that the ratio of the next term to the previous term is r. So for instance, ar cube divided by ar square is nothing but just r, or ar square divided by ar is r. So ratio of the consecutive terms is r, okay? That's what it is. Of course, we are saying we are dividing the right term by the left term, okay? So that's what makes a sequence a geometric sequence. We define geometric series similarly, so which is going to be a plus ar plus ar square plus ar cube plus dot dot. This is how you do it. And I can write it in a compact format, which you probably already know. Summation n is equal to 0 to infinity. Notice that the index begins at 0, a r to the power n. If n is 0, you're going to get the first term. If n is 1, you're going to get the second term. N is 2, you're going to get the third term, and so on and so forth. So this is a geometric series. Now, for a geometric series, I'm going to define something called partial sum. Okay, partial sum is S sub n. What it tells you, sum of the first n terms. Okay, S sub n is the sum of the first n terms. Now, here is something you may want to pay a little closer attention. And keeps going. Look. The power of r is not going to go up to n. It's going to actually go up to n minus 1. And that's when you're going to have the nth term. Why does that happen? Because we started at 0. And that gives us the first term to be a. So please pay closer attention. Sometimes by mistake, people would write ar to the power n. If you go to n, you are adding the n plus 1 term. Now, what I'm going to do, I'm going to go ahead and take this equation and multiply it by r. So it's going to be r times s sub n is going to be ar plus ar square plus ar cube plus dot 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 plus ar to the power n. Last term is going to be having a power of n. Now, I take this equation, the second equation, and subtract it from the first. So it's going to be s sub n minus r times s sub n. So look, all the intermediate terms are going to cancel out. If I subtract, okay, so let me write it out so that you can really see it. A plus ar plus ar square plus dot 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 plus ar to the power n minus. Remember, I am just writing out this first one. Now from this, I'm going to subtract this second one. So let me align this so that you can see it better. So it's going to be minus ar square minus dot 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 minus ar to the power n minus 1. That's the second to the last term. And the last term is going to be minus ar to the power n. Now, if I factor out s sub n on the left, I will have 1 minus r. And on the right, the intermediate terms are going to cancel out, and I'm going to be left with a, this term, minus a times r to the power n, or s sub n is equal to a minus a times r to the power n over 1 minus r. This, by the way, is called partial sum for this geometry series. So it's called partial sum. Now, how do you get the total sum from the partial sum? So your total sum is going to be s is equal to limit n approaches infinity s sub n. What it tells you is that how does this sequence, so you'll have a sequence of partial sums, s1, s2, s3, and it keeps going, okay? How does this sequence behave as n goes towards infinity? That means as you add more and more terms. And in the limiting case, if you add the entire series. So this is how it's going to be done. So we look at the behavior of partial sequence of partial sums. Okay, so remember, this is a sequence of partial sums. How does it behave, or what limit does it approach as n goes towards infinity? Now let's go ahead and look at the right side of this partial sum. S sub n is equal to a minus a times r to the power n divided by 1 minus r. Now for this series to converge, one of the things you kind of have to look is r to the power n on the right hand side. Okay, so this r to the power n, how does it behave? That's gonna kind of determine how things are gonna go. Just one observation. So let's look a simple case. So case 1, if your r, okay, your absolute value of r is less than 1, what's going to happen is the power n increases, okay, r to the power n, or absolute value of r to the power n is going to go towards 0. It doesn't matter what the fixed number is, or what the constant is, right? So this is going to go to 0. In that case, your s is going to be limit n approaches infinity a minus a times r to the power n over 1 minus r. That is going to be nothing but a over 1 minus r. So if your absolute value of r is less than 1, sum of the geometric series is going to be nothing but a over 1 minus r. And this is very important formula. It has a lot of application, and make sure that you do understand it. Now, what happens in other cases? So case number 2, when your r is equal to 1, okay? So in that case, of course, we have a problem. Divergence problem in the denominator. If r is 1, 1 minus 1 is 0. So we run into problems. So convergence doesn't work. So case number 3, when r is greater than 1. Okay. What's going to happen if r is greater than 1? If you take a number that is greater than 1, real number that is greater than 1, and you raise the power to infinity, or n goes towards infinity, what happens to r to the power n? It goes towards infinity too, as n increases, okay? It goes towards infinity. Consequently, what happens to this sequence? So s sub n is equal to a minus a times r to the power n over 1 minus r. Now, in that case, what's going to happen? This term is going to diverge. So the resulting expression, which is this whole thing, right? This whole thing is going to diverge. So the series will diverge. So just to summarize, the geometric series, okay, is going to converge only when the absolute value of r is less than 1. It's going to diverge otherwise. I hope that this discussion was helpful. Thank you very much.